doing? Are we ready? Ready to get started.
Like 2 days now.
What's today? Anyway, that's all we have left. Today, 2 lectures, and that's it. We have an in-class assignment today, so I got to keep track of time. I updated this and we posted it, added a few different example simulations we're going to talk about. Here are the 3 main parts of simulation that are the most important right there. Uniform distribution and the formula, which can be written all kinds of different ways. Normal distribution, NORMIND formula, and then known estimated probabilities, the VLOOKUP formula. Those are the 3 main ones. And you might remember, see, I think you talked a lot. No, stop looking at that. No, stop looking at that. And is this it? I think we talked a lot about this one right here. And the reason this example is a good example is because it's showing you examples of all 3 of them. If this were like, and I'm preparing you for what to expect on the final exam related to the simulation also. For example, you may get a question that shows this picture and it may say, what is this? B21. Write the Excel equation using cell locations and $signs, if applicable, that would be written if we could click on this and you could see. So you got to know. And you got to look at it and put logic together. See, this says direct labor per unit. So there must be something about labor up here. Right here. And you go, oh, labor. Look at this. I recognize this as a map. It's got intervals going from 0 to 0.10, 10 to 30, 30 to 70, 70 to 90. So there must be a VLOOKUP here simulating this because there's a map you're noticing. So then you start looking up VLOOKUP, what you see about it, and you write that right here just like it would be here. If I recall, on VLOOKUP, let me get this up here for you. It's going to say equals VLOOKUP, parenthesis, RAND, parenthesis, comma. Map, top left-hand corner. You go over here, right there. A10, $sign, colon, colon. Map bottom right here where the 47 is. So that'd be C14, and then comma 3. 3 because it's the 3rd column out of the 3 columns that you want the information to come back. And you start to go, oh, 43, it makes sense. 44, if you can scroll down, you'll see all the numbers in this column, all the way down are one of these. And you put it all together and you write that. The question may say, what's in this cell right here? Parts. And you look up here and you go, oh, here's parts. And it literally says uniform distribution right here. Oh, it gives you the smallest and largest value. Even if I didn't even put the words here, uniform distribution, or smallest and largest, you just saw it was from 80 to 100, you should be able to come to the conclusion that for that to be simulated, it's got to be a uniform distribution formula because all I'm being given are 2 numbers, a small and a large, and every number seems to be between those 2 if I could look all the way down here. And so you would use the cell location for the smallest, E8, plus RAND times, parentheses, cell location for the largest, E9 minus E8. And that's probably what's put in that cell, and that's what you would write as your answer. This next one over, first year demand. And you're looking up here and you're going, okay, let's see, demand. Right here. You don't see the words normal distribution, that's probably not there, but you do see it's giving you a mean and a standard deviation. There's the big thing. If it's not giving you a standard deviation, it cannot be NORMIND. Because it has to use a mean and a standard deviation wherever the cell locations are. And so you write this formula with the cell locations for the mean and standard deviation right there. And then maybe you're being asked to do this stuff. And profit is not being simulated, but instead is taking all the information that's been simulated so far and putting it all together to figure out the profit. And last week I said, you've got to know the profit and loss general formula, which is revenue minus expenses minus costs equals profit or loss. And then you start looking up there and go, well, I got to figure out where revenue is coming from, profit and loss. And you go, well, 9,120 units times $249 selling price would be my revenue. So that cell location times $C, $3, because we're always going to use $249 as revenue, no matter what the first year demand is. minus, well, I got this administrative cost, $C, $4, minus, I got this advertising cost, $C, $5, minus. There's all kinds of ways of doing this, but now I'm going to subtract labor and parts. Cell B21 times D21 minus cell C21 times D21. Now that's it. And now you have profit or loss. Revenue minus those overheads minus these variable expenses based on how many equals profit or loss. And you gotta, there's so many different ways I could have wrote that. I could have taken 249 minus 43 minus 94, then multiply it, then subtract the 400, 600. However you're doing, if this were a question on a quiz, and I know I could get 6, 7, 8 different answers, as long as that answer will get you to that profit or loss, that's fine. It's acceptable, it's right. As long as it makes sense. However you do it. All right, so there's a review about all 3 different ones. We saw all of them and how to recognize them. Maybe there's only 2 numbers, standard deviation, or if there's a map. If you're given a spreadsheet, if there's a map. Now, reading a story and coming up with these. But before I do that, we have to refresh some of the Excel functions you may not have seen in years, and some of you are probably going to say, I may have never seen these. And I posted these, and you need to know most of these pretty well. All right? I'm not going to go over max. I mean, you open this up, and you can go ahead and click on these. Equals max from B8 to B25 is picking the largest number in the group. Min does the same thing. Equals MIN. Here's the range of numbers, picks the smallest. Large is just like max, but the advantage of large is you could have it say, give me the second largest or third largest, not just the largest. So you have this last little component here at the end, comma 1 means the absolute largest, 2, second largest, 3, third largest. Small is just like min, but you have the advantage of saying, I don't want just the smallest number, maybe the second smallest number, third smallest number, or fourth smallest number. That's why I have that extra comma 1, comma 2, comma 3. This you need to know. Count. When you want Excel to count how many profits and loss you have all together, don't assume you copied and pasted it 999 cells below the one you wrote, so you must have 1,000. So you're going to go ahead and divide by 1,000 when you're doing some calculation. Don't rely on that. Instead, have Excel count the cells from the first profit loss or whatever is being done to the last one, because sometimes there's a cell in between that maybe it got skipped somehow and you're using the wrong number. Let it determine how many are being used. And then count if. Maybe you want to count how many cells are going to have profit over $500,000. You would do a count if and give it something to look for. Maybe you want, let's do it here. It's saying count if, look all through all of these numbers and count how many are 34s. And it's saying there are 4 of them. Like, show 1, 2, 3, 4. But you can have it count things like greater than 34 maybe. So let me just switch it real quick. I can't remember if I use quotations. Any experts here tell me, do I need the quotations here? I do? Okay. Greater than, right there, 34. So now I want to, this is telling me I want to count all the cells that are greater than 34. There are 9 of them. Let's say I were doing a profit and loss, I want to count all the cells that are less than 0. This will count exactly how many, out of the simulation, we did 1,000, this will count how many times it's going to show that we're losing money. In this case, there are none, because you can even have it count letters, I think. I can't remember if you have to have the quotations on this one or not. Let me try without. AB. So it's going to look for AB in that range. 0. So I do have to have it. I'm going to have this. There we go. So you can literally have it counting things. The most important part I've just showed you, though, is having it count less than 0. That's the main part of finding the probability of a loss in a simulation. I'm going back to this one again. Right here. This last one right here. If I had to count how many times out of 500, I could get the number of losses. And that's what's taking place right there. Matter of fact, let's check and see. There's several ways of doing it, but that count if is an easy way, and there it is. Count if from E21 to E520. You gotta see, there's a lot of cells not showing you. They're showing you the top and bottom, and that are less than 0. Now, if I want to turn that to a percentage, I would then divide it by count E21 through E520. So now let's count every cell that has a number in it from E21 to E20 and dividing it into every one of the cells between E21 and E520 that are less than 0. I just took that 47 out and turned it into a percentage, which will basically be 47 divided by 500, unless we miscounted the number of trials. And that's why we're using count in the bottom. Go ahead.
How did you make your numbers jump from 25 to 500?
I didn't. God, I can't remember where I got this. It's from the author somehow of the book. This is a problem that's in chapter 12, somewhere on, I can't remember what page. And so instead of showing the whole spreadsheet, they just show right there. I can't remember, there is a way to do this. Anybody? It's called hide. Is that how you do it? Look at these other things. The mean profit. It's using a command was on our list to learn called average. And it's looking at all of those and finding the average so we can see what's the average profit we could expect. If we go forward with this, as long as we stay in the middle and everything goes according to plan, right down the middle, we'll maybe average over $700 profit. But look at what happens. What's the most we could lose? What's the most we could gain? Jump down here. Min is being used. And we could lose over $1 million if what I call the perfect storm. Labor costs are as high as they could be. Material costs are as high as they could be. Revenue is low because our demand was lower than we expected. That causes the biggest loss. It's in your first year, you have something like this happen. It pretty much, is the worst thing that could happen to you because of your whole plan on cash flow, and if you got a loan to do this, being able to pay it back. And it kind of sinks you, and that's why you want to, when you're doing something new, and you're using simulation to make the decision whether you want to spend a couple $1 million to do this new adventure, whatever it may be, that's why it's so important to figure out ways to get that probability of a loss down so much so that this doesn't happen and put you out of business. Depending on how much you have in excess cash, if you got $1 billion sitting aside, this is no big deal. You may not even simulate, let's just go for it. But if $2 million is a lot of your cash, or you even have to borrow to get the money because you don't have enough in cash, this is a big deal. Yes, it could pay off big, but if just a misstep, the wrong situation, the perfect storm, we had no idea this was going to happen, this whole economy was going to sink here in the next 12 months. A lot of people didn't see what happened, the financial crash of 2008 hurt tons of businesses for months and months and months, especially right away, and that's why the layoffs were so huge. I can remember there was reports after the financial crash in December, January 2009, February 2009, March, where over 500,000 people were getting fresh laid off every month. Over 500,000 every month getting laid off. And our economy was just like plummeting so quickly. And you just decided to do this right before that happens, having no idea that was about to take place. And it's going to wipe your company out. And you're going to go, wow, we would have never done this if we had any idea that our revenues were going to be cut by 40%. A lot of companies saw, even if they didn't die, they saw their revenues cut by 40% in a very short period of time. And it's devastating for a lot of companies. They're not prepared. So that's how important simulation is. So there's your review. And a couple more commands, and then we're going on. Yeah, where are they here? We did the mean already, which is average. If. Oh my God, you've got to know if statements. You've got to know if statements. You've got to know if. If statement says, at first, you're telling this if thing. Hey, if this happens. So that's the first part. This is like a test. If this is less than that, if this is greater than that, if this is equal to that, whatever it may be. And then after the comma, if it's true, if the answer is yes, that is true, you're telling it what to do. The next comma is if it's false. No, that's not true. That's not less than or greater than whatever. Then you're telling it what to do. It won't do both of these. If it's true, it'll do this. If it's false, it'll do this. And that's what's the advantage of an if statement. It opens up the opportunity to do all kinds of things. If statement after if statement after if statement. You can imagine anything to be simulated if you understand how the if works. In this case, the question we're given at the test is, if B8, which is where, right here, 33, if B8 is less than 50, comma. Now, if it's true, doing whatever's right after the comma, but if it's false, it's doing what's after the next comma. So if it is true, so it says, put a B here. Whoops. Is that what it says? Count. If it's true, count if, it should be just count. Right? No, count if.
If that one's less than 50.
Count if, all the way through here, all the ABs, which are 1. If it's false, put the word no there. But it's not no, it was true, so it counted the if. And let's do another one. Let's switch it up. Let's make this greater than. Now it's going to be false, and it should put the word no there. It will skip over counting the ABs. And there you go. If you haven't used an if before, and this is new to you, you've got to catch up. Because you should be at the point to where you've experienced using if, because you have several other classes that you have to use these if commands to put things together in homework assignment. And on that big project, you got to do that big simulation. It's if, and then if. Ifs within if, saying, well, if this, then do this. Well, if that's not true, then what about if this, then do this. Well, if that's not true, what about if this? You have all the no's are asking another if, one after another. And so you've got it in your future, so you've got to learn that one, if anything. Standard deviation, we've seen before. And then I have, over here, just an example of RAND Princy. We're using that because all of these simulations, all of these commands, so you're familiar with that by now, I hope. Here's uniform, just an example of it. Just happens to be using B11 plus RAND times B17. This must be the largest number probably, minus B11. And then here's NORMINV using the mean, which is right here at G20, and the standard deviation right here at G24. These are all examples that are posted. Again, the most important ones that you need to make sure to learn is if, count if, count, max, and you should know these. But if these are new to you, this if and count it and count, you need to understand and learn those. Those are the most important ones. Okay, so now, other ways it can be used. Wait. Go. Wait, let me get on there. Can I close it?
Excel.
Thank you. And right here.
So for the norm and the uniform, how both of them say use the RAND parentheses. Is it using that same number that's in L8, or is it making a new one?
It's making a new one.
Oh.
If you use the one in L8, you would have to put L8 in there. Yeah. And then that would change every time. Notice though, every time, even if I put a space here, what is it right now? 0.7289, right? So now it's 0.0957. Now it's 0.90. So you could refer to that cell and it would give you a new one every time, but it's picking its own new random number. So, but this is what you do with simulations, so you can see the results and see what's the new results and the new results. Just space. That's it. Just like that. Let's go to this one that we were just talking about, made by them. Let's see, will this change or is this locked in? Oh, it's changing. So 39 out of 500, 41 out of 500, 51, that's probably the most we'll see, 48, 41, 40, 34. If I did this like 30 to 100 times, you're marking down each how many number of losses each time, it will start to form this. And there'll be a whole bunch of them right here on the number line, and you'll go, you'll make your own number line. You'll go, oh, look at all of these that come up. So here's the mean amount of mean losses. It's pretty much telling you this is the percent chance based on all the information you've given about labor, about material, about revenue. There's the most likely number of chance of a loss by taking that and divide by 500, however many there are. Okay, now we're here. Here's an example of how it's being used in inventory. Now we're going way back to chapter 10, which was like our second chapter for this class. But in that class, we talked a little bit about the reorder point. And the reorder point is all about is about when to reorder. And many companies, they live and die off the reorder point for inventory management. And if they say, we keep having too many left over, they will lower the reorder point, meaning we'll let a couple more days of sales go by until we reorder and see what happens. Because it's all about reordering at the point of however many you have that you'll go through during the time you're waiting for the new order to arrive. That's the reorder point. But what do we reorder to? Called the maximum inventory level. In this example, they keep reordering to 100. Whatever they're down to at the end of the month or whatever they get to, they order however many it takes to get back to 100. And then they have sales again, and then they get it back to 100. But their deal is, and these are routers, I think. Is it routers? Wireless routers they're selling. This is just one item. They sell it for, they cost about $75, they sell it for $125, so they're making $50 gross profit off each one. So there's that money. But they went ahead and figured out, and they, right now, they sell with a mean of 100, standard deviation, mean of 100, standard deviation of 20, here's the mean. If we were to simulate sales of wireless routers for this company, which one would we use? Uniform distribution? Which one? The norm IND. As soon as you see a standard deviation, if we were going to simulate this, it would be equals NORMINB, parenthesis, RAND, parenthesis, comma, whatever the cell location is, where the mean is, comma, the cell location for the standard deviation, and then parentheses. 100 units, we make $50 off each one, but the deal is we keep taking the inventory back to 100, and they do their inventory monthly instead of waiting for a reorder point. So they have times where sometimes they run out of wireless routers before they even put an order in. And they've come to the conclusion that for every router we have too many in inventory, we don't sell all 100 of them, however many we're carrying over, costs us $15 for each one. And if we don't sell, if we do sell them all, and we could have sold more, where is it? $30, taking goodwill into consideration. If somebody coming to get a wireless router from us, and they left and either got it somewhere else, and maybe some did come back and some won't, the estimation is $30. So they said, let's simulate it. We know our demand is around 100 with a standard deviation of 20. We're going to simulate it at 100, and we're going to go ahead and calculate how much we lose in holding costs, remember the holding cost for inventory, and back order costs, loss of sales. And we did this, and forget those, right here. First month, 79, but we had 100. So how many did we sell? 79. What's our revenue? I forgot the story. It says we're selling each one for how much? We're doing gross revenue, which is $50. And whatever we're selling it for, and whatever we bought it for, we're making $50 gross profit off each one. So $50 times 79, there's our gross profit. Holding cost, 100 minus 11, or what is it, 21? Minus 79, 21 times $15 for each holding cost. We subtract from our gross, here's our net profit. And it goes on, we simulate again, and again, and again. And maybe there's 500, 1,000, here's just 5 of them. Now, we're saying, what if we didn't take it back to 100, but took it back to 110? From now on, we're ordering 10 more. And we're starting each month with 110 because we notice, you know, we have some losses here. Oh, I'm sorry, we have some losses here from not having enough, and we have some losses from having too many, but we have bigger losses from not having enough. So we said, let's try 110. Here's our net profit at 110 after we ran the simulation. And all we had to do, by the way, is just change one number. I did this one right here, and I posted it, I think, I'm pretty sure. Here's the inventory level at 100. All right? I copied and pasted this down 30, I think, right there. And here is the mean. So at 100, I'm gonna run this, leaving the inventory level at 100. Watch the mean net profit. 4312, right? 41. Try to give me an average. What do you see after I run this over and over? The net profit, would you say, is around 4,200, 40 more, less?
4,205.
So around 4,200 or something? Now, you have this set up using cell locations. All you got to do is say, we're now going to have 110 in inventory. Keep moving it up to 110 instead of 100, which should less shortage cost, maybe more holding cost, but this is $30, this is $15. Let's see what effect this has on the bottom line, our net profit. So I'm going back down here to the bottom. I'm going to just hit space and just keep watching. 44.76, 44.62, 42. I'm saying this average is more like, well, there's a 39, there's a 4,000. Maybe a little above 4,200. Do you agree?
What are you doing on your keyboard?
I'm just hitting space, enter, space, enter, space, enter.
For what?
I'm just moving this down so it changes the whole simulation recalculates all the random numbers involved every time you change anything. It's like rerunning the whole thing.
Are there cell locations in your big portion, all of those just change and then recalculate?
It's recalculating everything because demand is using normal IMV because here's the mean, here's the standard deviation for demand. The amount sold is saying, hey, if this is where's T3? If this is over 110, then we can only sell as many as 110. But if it's less than 110, we sold as many as demand. This cell here, gross profits, taking the number we've sold, multiplying it times the price. Where's the $50? Gross unit per unit, $50. The holding cost. This is just subtracting the demand from the inventory. And if demand was higher than the inventory, if the inventory was higher than demand, we had to leave some there.
So do you have to refresh each row?
Everything that is being simulated that's using a random number is going to be a new number anytime I change anything on the spreadsheet.
And you've got to go through and do that row by row?
No, not at all. Watch. I'm just hitting space. See how all the numbers are changing on their own. And
You're
then,
putting a new number in every time.
all I'm doing is getting a new average. I'm having the average of all of these net profits just to compare. I'm comparing 100 in inventory compared to 110 in inventory to see how it affects the bottom line here. We should see our holding costs go up, but our shortage costs go down because now we have 110 to sell instead of only 100. And demand's been maybe high usually than other things.
So when you put a random cell in his space and
Any random cell in his space, yeah, it just changes the whole thing. So now it did 30 simulations again, based on our inventory going to 110, and it says your average profit based on those 30 simulations is 4,380. You just hit the space, enter. Did everything change again? Now we're at 45.67.
When do we know when to stop? To get like that perfect number.
You could, 30 is the minimum you should do in any statistical simulation, any calculation whatsoever. 30 should be your minimum. By the way, stats should have really pressed that. They did? Good, okay. In statistics, that's a big part of statistics is 30 should be your minimum sample size in any experiment you're doing of any kind. So if you notice, I took this to at least 30. But then, would I do this 30 times?
Well, no, because then it just gives you, it does the whole thing 30 times with random numbers. So could you just do a huge sheet of like?
Yeah, if I do 1,000, then I would take whatever the outcome is, period. I wouldn't even do it. I may do it multiple times just to see if I have, once in a while you get something that's maybe not right in the center. So if you do it a bunch of times, you can kind of find your own center. Like, if you notice, this is different every time. Once in a while, you'll see one that might be, start with 3,000. And once in a while, you might see one that starts at 5,000. But I'm trying to find that center, so that's why I kind of hit it a few times.
Does that have a lot to do with only having a 30 sample size?
Yeah, the smaller sample size, the bigger this range will be. That's right. If I had 1,000 simulations, that narrows this down. It narrows it way down, where it would be much easier.
Does
But-
average have random number generator? The average?
Say it again.
K38, does that have random in it?
No, this is only finding.
Why does that one change?
Because everything else.
Because these all are changing,
Oh, yeah,
because
yeah.
these are all using all random numbers. So, yeah, let's, look at this,
Everything uses.
look at this net profit. So what's happening here with net profit is just taking gross profit minus the holding cost, minus the shortage cost, and coming up with that number. Anyway, the point of this, let me go back to this right here, is that had we done enough times, you would have noticed when we got to 120, that the average was higher even than 110, even than 100. And when we got to 130, you would have noticed that the average is starting to move down. And 140, you would have seen our holding costs get so high that it brings the average way down. And this is how you find, the sweet spot. We need to change our inventory to where we're having it back up to 120, not just 100. We're losing too much money from missing out on sales, is what this simulation is trying to tell you. That you need to increase that maximum inventory. Instead of sending it to right what you think sales are going to be, because of there's such a high backorder cost of losing a sale, and even though there's a cost of having too many, that high cost of losing a sale outweighs it to the point to where we want to have 20 extra in inventory than what we usually would sell. And it's worth it, because that time that we have more than 100 people come in the door, then all these sales are generating enough on average to get our profit average. This, by the way, is very much like a problem that's, I don't think it's in the back of your book anymore, and I didn't put it on the schedule to talk today, but airlines do this, been doing this for years and years and years, where they will purposely book more passengers than there are seats available. Did we talk about this?
Yeah.
Did we a little bit?
In a previous chapter.
Yeah, and there's a simulation where you are the airplane, you're the airline, and you're testing the theory. And you've come up with some probabilities of 32 passengers showing up, 33, 34, based on the information. And you use those probabilities and you say, what if I went ahead and booked 32 passengers for a flight, even though there's only 30 seats? And you know there's no way you can get 32 passengers on that flight, but you purposely book it. And if you've ever been on a flight that gets overbooked, they come on board and they offer money. Hey, $100 if you get off and take the next flight, 200. They come on and offer more money, more money. They just keep offering things because they know they got to get something off the flight. Because the person who showed up before the plane took off says, I've got to get a seat. I've got to have a seat. So they're offering to have someone willing to come off the flight. And they take that into consideration. And when you hit the simulation, every time you overbook and got to kick someone off the flight, you're subtracting it from your gross revenue, your gross profit. What they found out is, even though there's a significant cost of booking too many people on a flight and having to ask someone to leave and paying them money to catch the next flight, the airlines all figured out that they come out way ahead overbooking, even though there is that cost. Because having a plane with empty seats was so costly for them that they realized we come out ahead paying passengers that we have to get off the flight. That it costs less to do that than to have not enough passengers on the flight. So that's happening, it's been happening for years, and it was through simulation that you can see why that would be a better thing. It literally tells you how many you should be booking. You'll try it with 32, or try it with 33, or try it with 34, and now the profit's going back down again. And you find the sweet spot, you go, we should be booking 32 seats. So there's an inventory example. We're going to page 528 On the book, I forgot to bring again. We're going to 528.
Guess I'm going to be pretty close.
All right, top of the page. We're going to look at this. Start by telling me what kind of simulation command you would use, uniform, whatever.
Blurry.
There is no blurry command, but in the end. Here we go. You ready? This company says we want to simulate the price of our stock per share, and we look back at how the price of our stock has changed over the last, I don't know, they probably looked at maybe 50 or 100 trades. And they counted, out of those 50 or 100, every time it went up, down $2, all the way down when it went up $4 a share. And then they divided by the number and they came up with this probability. There was a 5% chance. Out of the last 100, 5% of the time it went down $2. 10% of the time it went down $1. 45% of the time. All right, so this is a problem on the quiz. Or quiz, you have no quizzes. This is a problem on your final exam. And it may say, prepare the stock price story here for simulating the stock price based on this information. What your first step is, you need to map this.
It's VLOOKUP.
Thank you. Exactly. Because you're being given probabilities, this is the VLOOKUP. And now we're going to map it real quick. I'm going to go fast. 0 to 5. Start at 5, add 10 to it. That takes me to 15. Start at 15, add 25. 25, what does that go? 40? I'm going to, left off at 40. The next one is 20%, so I'm going to 60. I left off at 60. The next one is that 20% again? Yep. That is 80. I'm going from 80 to the next one is 10%, which is 90. I'm going from 90 to the last one, which is 10%, 100. Now, I'm preparing it for Excel. You ready? Dot, 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 dot. There you go. Now it's ready for Excel. Right? It just makes it easy. And the third column would be minus $2, minus $1, 0, plus 1, plus 2, plus 3, plus 4. And if this is a quiz, then maybe you already have the math. And instead, and then I say, the random number that just came up. Matter of fact, here's 3 random numbers. Here's 3 random numbers. I'm taking them off on the fly here. 0576. 0.2997, 0.7612. The stock starts at $39 a share. $39 a share. You're going to tell me what is the price per share after these 3 simulations. Are you ready? The price continues after each simulation wherever you left off. We're at $39 a share. First random number, 0.0576. What do we do? Add, subtract, or stay the same? What is it? I can't hear you. Minus 1. So now we're at $38 per share. Next random number, Now, somebody just got lost. Someone said, why did you subtract 1? I can hear you. Where are you? Thank you. Thank you. Cool. I didn't hear you. I heard him. I only heard 1. I don't know. What they're doing is they're matching up the random number to the ranges here. And 0.0576 was between 0.05 and 0.15. And that represents, subtract 1, this is subtract 2. Subtract $1 it represents. What's this next one? Break even? Break even, add 1, add 2, add 3, add 4. And it lined up here, so we subtracted $1, so now we're at $38 a share. The next random number is 0.2997. It's between these two. Price stays the same, right? 0, no change. Next random number, 0.7612. Is that these two? Which says plus 2. At the end of 3 simulations, the price per share is $40. That's a quiz. That's our final exam question, and showing that you understand the map, how to read it, how to line up the random numbers to the ranges, and determine what would happen.
So those numbers right there are the random numbers?
I made them up off the top of my head. Yeah.
Do you have to have the $sign in there?
No.
Or 39?
No, I mean, it doesn't matter. I'm looking just to see that you knew to subtract one, to not change, and then add two based on the three numbers.
Those three random numbers, how are those gonna be given to us?
On the quiz, instead of you generate a random number, I'll say, and here are three random numbers.
Okay.
You know, use these three random numbers to simulate what the stock price would be after each one of these numbers and what the end will be. And you would show them the work. You'd say, lines up here, subtract one, now we're at 38. This one lines up here, no change. And then you go, oh, this one lines up here, add two. The ending number is $40 a share. All right, let's look at another one. We're going to page 530. Number 14, just part of this. You ready? Diamond, you're
Yeah.
jumping in with which command I should use. You ready? A building contractor is prepared to bid on a new construction project. Two other contractors will be submitting bids for the same project. Based on the bidding practices and the requirements for the project, the bid from contractor A is going to be described as a uniform distribution between 600 and 900,000, 600 and 800,000, excuse me.
Uniform is it?
It literally says it. Usually says it. And 600,000, right? And there you go. And what was the other one? 800? Let's, wherever this is located on a spreadsheet, it'd be the 600 and 800. If we were to write this out, I'm going to purposely write this uniform command differently than the ones in the past because there's so many different ways. I just want you to see another way, but it does the exact same thing. Equals. I'm going to go with whatever the cell location where the largest number is, which would be that 800,000, minus. I'm going with parentheses right away. Cell location wherever the largest is, minus the cell location wherever the smallest is, times R, A, N, D, parentheses, parentheses. Order of operations says it's going to do what's in the parentheses and multiply it right there first, before it subtracts. It will always give you a number between 600 and 800,000. I just wrote it a little differently than the other one, which was the smallest plus, and then I gave the random R-A-N-D times. It could be after, it can be before. I'm just showing there's so many different ways. And that's how you simulate this. And that I would say, and now tell me what the bid on this contract will be from this contractor if the random number is 0.45. And your final exam literally has 0.45. And you're using this formula you just wrote. And all you got to do is take 0.45 right there for the random number times the difference here. Was that 200,000? So 200,000 times 0.5 is 90,000, I believe. And then you subtract it from 800,000, and we're at, what is that, 710,000 is the simulated bid for that contractor based on that number. Now, somebody needs to ask me, how did I get this 90,000? You know? Do you really?
Did you remove the rand and put 0.45?
I removed that 0.45, and then I knew the largest minus smallest, 800 minus 600 is 200,000. And then I took the 200,000 times 0.45. I knew it was 45,000 for every 100,000, so then multiplied times 2, 90,000. Is that right? Anybody got a calculator? And then I just subtracted from 800,000. So, no matter what random number I give you to replace this R-A-N-D, you're always going to calculate a number between 600 and 800,000. Let's run over the other one. We weren't going this far, but let's keep going. Contractor B can be described as having, their bids are a normal distribution with a mean of 700,000, standard deviation of 50,000.
The
Normal, IND, because you got a standard deviation and mean given to you. So one contractor, we're using the uniform distribution, but the next contractor, we got to use N-O-R-M-I-N-D, parenthesis, R-A-N-D, parenthesis, comma, wherever the cell location is, where the mean, which is going to be 700,000, wherever that cell location is, where the 700,000 is, comma, standard deviation of 50,000, wherever the cell location is for that 50,000, parentheses.
Okay.
Whoops, no commas in your numbers here. I don't know, I guess you can, but I just want to make sure it doesn't confuse it with a comma. Go.
So back to the question from the last question, did How did you get that?
How did I get what?
How did you get 710,000?
I replaced this random with the .45.
Yeah, but I'm using a calculator and I can't get that.
Oh, okay, maybe I made a mistake, help me out. You take 800,000 minus 600,000, you get 200,000.
Yeah.
200,000 times .45.
It's 90,000.
Is it 90,000? 90,000, then I subtract 90,000 from 800 and I get 710.
Okay.
Is that what you got?
I did my
With
own.
your calculator?
I can learn to understand you much better if I can get familiar with the way you talk.
Okay, go to slide 30. I think I can give us slide 30 because I know you need it. Slide 30 are some of the stats that are at the end of many of these simulations. These are the kind of things you want to find. They calculate the mean. This happens to be referring, I think, to this one here, which is this the inventory one? No, this is whatever the sell locations are at the end of this. It's referring to this profit right here. So it's looking at all those profits and just showing you. Find the average, find the standard deviation, find the minimum, find the maximum. Here it is. Count if, between those cells, all the profits that are less than 0 divided by count all those cells that have numbers in them between here and here. All right? It looks like it was 1,000 simulations. And out of those 1,000, we're trying to figure out how many were a loss in profit. The loss instead of profit, and divide it by the number of simulations. They turn that into a percentage chance of a loss. So those are on that page. Now, all right, we're on this one. I, at this point in time, do not want to put this on a final exam because people start to struggle with what are called time simulations. All right, this simulates a time series, and we're trying to figure out, in this example, this airport says, hey, we want to change international flights that are coming in, how they go through the passport and baggage inspections. And they want to change it in a way that they went ahead and did a test run, and they said, if we do the passport first, we think that there's a 20% chance it will only take 20 seconds. What do we got here, 40%? There's 40 numbers there, right? 40% chance it will take 40 seconds, 30% chance it will take 60 seconds, and about 10% chance it takes 80 seconds. And then there's a second station that people would go after the passport for to have their baggage looked at. And we've got 25%, they can go right through. What is that, 60%? Is that right? Is there 60 numbers there? Anybody get what I'm looking at here? 60 seconds, 10% chance, 120 seconds, and then we have a 5% chance it could take 180 seconds. So here's how this works. That passengers are coming in, they're going to passport first, then they're moving on to baggage. But here's the deal. When someone leaves the passport station and they're heading towards the baggage person has to be available for them to walk right up. Or they'll have to wait if the baggage is still with the previous passenger. So here's how it looks. Starts at 0 time. We're going to simulate the amount of time it takes for the first passenger to have their passport looked at. VLOOKUP, here's the map. It brought back 40 seconds. So the random number must have been between here. The end time, now that passenger is done with the passport, is at 40 seconds. They're the first passenger.